Hello, let us see how a simple comparator works. So here we have configured UA741 op-amp from Texas Instruments as a simple comparator. So you can see here there is a reference voltage of 3.3 volt given to the non-inverting terminal, and then here there is a sine wave that is being applied. So if you can see here, this the peak to peak voltage is 5 volts. So as the offset is 0, we have a 0 to 5 volts waveform here. So now what we are doing is basically we are applying a sinusoidal wave to this non-inverting terminal, and then the op-amp is provided a voltage of 7.4 volt. So 741 has a voltage range from 5 to 15 volts. So we have provided 7.4 volt, and then there is a load of 10k. Here we have connected a simple output where we can probe the voltage for our measurements. So this is a simple comparator circuit with input to non-inverting terminal and a reference voltage to inverting terminal. So if we run a transient analysis here for a period of 1 second, you can see here there is a waveform, so we will see separate curves. So here you can clearly see, we will like clear it to 1 or 2 waveforms. So you can clearly see here that when the VG1, so here 1 millivolt. So when the VG1 has exceeded the 3.3 volt around 1.1 milli seconds time, the output has gone high, and again when it has gone below the VG1, the sinusoidal waveform has gone below a specific voltage, the output has gone low again. Output has gone low again. So now in this scenario, this is working as a comparator. This is working as a comparator, and then we can see here the output is varied based on the input voltage. So this is how a simple comparator is operating here. Now in this scenario, let us assume I don't give a reference voltage to this comparator. We have kept it open, and we are just giving a sinusoidal voltage to a non-inverting input, and in this scenario there is no reference voltage, and we will see how the output is varying. You can see here, so the output, we can see here there is a waveform VG1 provided, and now the output is stuck at a specific value even though there is a sinusoidal waveform provided. So this you can clearly say that the output is stuck at a specific value, which depends on the kind of load we have connected. So here we have connected 10k and we have seen 5.6, and then if you do the transient analysis here, you can see here instead of 5.6 it has gone to 5.12. So this is understood because the output of a op-amp always output voltage of op-amp depends on the load that is connected. So this is as per the waveform you see here. The maximum peak output voltage depends on the load resistance. So that is from the 741 op-amp data sheet. So here also, depending on the load condition, the output has varied. So the scenario to understand here is that when there is no output connected to the negative terminal, and then there is a waveform that is connected, so the output remains high, or we can say it is it cannot be determined. Now in this scenario, let us see if we connect the waveform to a negative terminal and then the positive terminal is off. So you can see here. So this is stuck at a low level because we have given this to a negative terminal and the positive terminal is left open. So this is how a comparator works. If one of the terminal is disconnected and one of the terminal is provided with some voltage or some reference. So we can clearly say that the comparator functionality is not performed as desired and the output voltage is struck at a specific voltage if one of the terminal is left unconnected.